Okay, this question says that you have a sample of nylon 6,6 and it has an average molecular weight of 250,000 grams per mole. It then asks, what is the degree of polymerization for this polymer? So, to answer this question, the degree of polymerization, which we normally write as small n, that's equal to the molecular weight divided by the mer weight, right? Or in other words, what that's saying is that if you have this really long polymer chain, and in this polymer chain, you've got a series of repeating segments, right? Repeat over and over. It's basically asking you to count how many of these segments are there. 1, 2, 3, and so forth. Except that typically the numbers are far larger than just a few. It's typically on the order of several hundred, several thousand, right? So what is it in this case? Well, to start with, calculating n would be straightforward because we're given the molecular weight as 250,000 grams per mole, 250,000. What we need to figure out then is the molecular weight of the mer, the repeat unit. Well, here's our repeat unit shown here in the square brackets. Now, the reason they call this nylon 6,6 is because there's sort of two segments in this repeat unit. One of them has a carbon, a carbon, a carbon, a carbon, a carbon, and a carbon. That's 6 carbons on the left-hand side. Then it's got this nitrogen, and then carbon, 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 6 more, and then another nitrogen. So we can go ahead and count up how many carbon, nitrogens, oxygens, hydrogens, everything in there. So let's start with carbons. Carbon, we have 12 of them, and they're each multiplied by 12.01 grams per mole. Now let's move to the oxygens. Oxygens, we have 1, 2 labeled. So there are 2 of those. They're each 15.999 grams per mole. Now let's move to the nitrogen. Nitrogen, I count 1, 2 of those as well. So 2 of those are 14.006 grams per mole. And then finally hydrogens. Hydrogens they're not always labeled on these diagrams, so you have to count them up. For example, this carbon can only have 4 bonds, and 2 of them are occupied with the oxygen. You've got a carbon on the left and a carbon on the right, so there's no hydrogens on that one. But this guy, he has hydrogens above and below. This one as well, so we can sort of tag those. We'll count them up in a moment. The nitrogen normally only has 3 bonds, so it's got one to the left, the right, and the hydrogen that's shown. You got carbon with these. These are all going to be hydrogens on these carbons as well, and that's it. So let's count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8. And we've got 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I count 22 hydrogens here. Those are each 1.0079 grams per mole. So if we add that up, we can figure out the molecular weight of our repeat unit, and I get that it's equal to, I get a value of 226.3 grams per mole. So now that we have the molecular weight, we can go ahead and divide the average molecular weight of the whole chain by the molecular weight of this repeat unit. So this is going to be equal to 250,000 grams per mole divided by 226.3 grams per mole, which I get to equal about 1100. So that's how many repeat units there are in this chain of nylon 6,6.